Whether you like enjoying a beer on a hot weekend afternoon or hate the taste of the alcoholic drink, there's actually a ton of science that goes into creating it. Science may be the last thing on your mind when enjoying a cold one, but it's always good to know just how what you're enjoying was made. Science contributes to the type of beer, the different flavors, and how it's alcoholic. So let's learn the science behind brewing beer. First, we'll look at the ingredients. The main ingredients in any beer are water, malted grains, hops, and yeast. Hops are the flowers of the hop plant, which are used for flavoring. The only other uses for hops are in herbal medicine. With these four ingredients, you have everything you need to make beer, but the combinations and processes make all the difference. All of these ingredients are boiled together for set amounts of time until the final mixture is filtered and sent to fermentation. Mineral contents in your water source can make a huge difference to the type of beer that you brew. Calcium and magnesium in your water, otherwise referred to as hardness, affect how the yeast grows and metabolizes the sugar in your brew. Bicarbonate, or HCO3, in your water also affects the pH of the beer during the fermentation process. If you're wanting to brew a beer that is more caramely or toasty, then you'll need to roast your grains more than usual. Darker roasted grains result in grains that have more degraded glucose molecules, ultimately resulting in a darker beer. Hops in beer are the main driver behind modern beer, and without them, our pints would be a little less enjoyable. The hops act as a surfactant that allows bubbles to be trapped in the head of the beer. If hops aren't added to the water, it would have much less surface tension, resulting in no head and a bitter taste. Hops can provide certain flavor notes to the beer, but their main effect is stabilizing the brew to allow our palate to taste all of the different bitter and sweet notes of the beer. Without hops, we would have a hard time tasting the flavors and ultimately enjoying the beer. Next, we move on to fermentation. Yeast is the big player in this process, and it's the most important element of making it alcoholic and carbonated. These little cells seek out glucose molecules in beer left by the grains and hops. By fermentation, the yeast converts the glucose into ethanol, or alcohol, and CO2, which is the carbonation. The specific chemical equation is what's shown right here. This is the general equation for fermentation, but specific products can be influenced by the type of yeast used in brewing. Ale yeasts are top fermenting, which means they can ferment at higher temperatures and ultimately produce more esters, which are organic compounds easily described as fats and oils. Lager yeasts are bottom fermenting, which means that they ferment at lower temperatures, producing a crispier taste. Wild yeasts are seldom used in the brewing process, but when they are, they produce a mixture of compounds that are more acidic and an acquired taste. These are rarely used because the exact flavor profile is harder to control from a brewing perspective. During the fermentation process, certain molecules can have different effects on the final flavor and feel of a beer. The length of carbon chains in alcohols, the amount of alcohol, the type of esters, residual sulfurs, and carbonation levels all contribute to the final flavor profile of the beer. Factors that can influence the fermentation and alcohol content of a beer are mineral content, temperature, pitch rate of the yeast, aeration, and length of the fermentation process. Brewers closely control all of these variables to get flavors that they want out of the final brew. Esters produced in the fermentation process can be predicted and controlled to produce certain flavors as well. Ethyl acetate is the most common ester in beer and smells like nail polish remover. In order to smell this ester, a high content needs to be present in the beer, and this usually isn't the case, which is why your beer doesn't smell like nail polish. Isoamyl acetate is another ester that smells of bananas. This ester is found in many Belgian and wheat beers. Ethyl butyrate gives a hint of passion fruit or pineapple to the beer, bringing up the sweeter notes. Finally, another ester that you probably have tasted or smelled is ethyl hexanoate, which results in an apple-like flavor added to the brew. As for the science behind popular beers, we can dig into some of the most popular beers to see just how precise every aspect of the brewing process is controlled and how it's made. Budweiser is a Pilsner malt, meaning a lighter golden beer with a sweet hint and medium amounts of hops. They use a type of yeast named S. ovarum and ferment their brew at 15 degrees Celsius for 2 weeks and add wood chips during the fermentation process to help the yeast grow. Finally, the beer is heavily filtered and force carbonated. Guinness, a darker beer, has dark roasted malted grains that give the color and light roasted malts that provide sugar for fermentation. They use a yeast named S. cerevisiae and ferment at 18 degrees Celsius for 2 or 3 weeks. The beer is then filtered and carbonated with nitrogen, which results in the creamy taste due to nitrogen creating smaller carbonation bubbles. Finally, another beer to look at is Rodenbach. It has lighter roasted malts and wheat with low to medium hops. They use wild yeast with spontaneous mixed cultures to ferment at 18 degrees Celsius for 2 to 3 weeks. The beer is then filtered and fermentation continues in the bottle to add natural carbonation. Smaller breweries will use natural carbonation in the brewing process because the end product can vary slightly and filtering is needed less. For larger breweries like Budweiser, filtering is a large aspect of their production, which removes any natural carbonation, so they must add in carbonation after the fact. For many, the taste of forced carbonation versus natural carbonation makes a huge difference in the beers that they enjoy. After all of this science is completed, you get a final brew. There's really no reason to store beer for long periods of time like other alcohols because the flavor profile is already completed at the time of brewing. In fact, most beers do have an expiration date of within a year, even shorter if natural carbonation is used. So be sure to drink up, but of course, responsibly.